So that's my research. It's actually related with experiments. Experiments trying to look for impossible things, at least in the framework of the established science we know by now. So since that's the last talk and you have been sitting for so long, I want you to do some exercises. So some of the text are, you see, you have to bend your head. Anyway, so the title is related with testing quantum mechanics in the underground lab in Gran Sasso, which is not really properly an underground lab because it stays under a mountain, which is the Gran Sasso mountain in Italy. It's 150 kilometers far from Rome. And I'm going to tell you something related with two researches we are doing there, trying to test quantum mechanics. One which was generously funded by the FQXi, a grant of a couple of years ago, related to its collapse models, while the other one by the Templeton Foundation, which has to do with impossible atoms, looking for violations of the Pauli exclusion principle. You might have noticed here I'm citing Shakespeare in relation with Schrödinger cat, which might look rather crazy, but one of the things we try to do in the collapse models, which are, well, it's not an interpretation of quantum mechanics, but there are models which might show the way towards a different theory, which includes, as a limiting case, the present quantum mechanics. Namely, what we try to do is understanding how we can go from a superposition, namely to be and not to be, to what we have, all of us well known, to be, are or not to be. And that's me, according to my electronic engineer, looking for signals under mountain. It's not that I do this every time and every way. That has been actually born by the fact that my group is expert in developing radiation detectors, which we normally use for quantum chromodynamics, exotic atoms in accelerators, but I think that that's quite limiting, so we wanted strongly to use them for looking in some foundational issues. Good. So what we actually do in Gran Sasso, so for the moment keep your eyes on this side, so we look for a signal which is called spontaneous radiation, which means a radiation which shouldn't be there in standard quantum mechanics, which instead appears in the collapse model like Ghirardi-Rimini-Weber-like, but not only that one, and which would solve the measurement problem, might have something to do with gravity. And I had the chance to have nice discussion with Loes Diogi and also with Penrose related to this, so how this can also be related with gravity, kind of gravity-induced collapse models. So we measure radiation, which I tell you it shouldn't be there. It comes in the collapse models, especially in continuous spontaneous localization. And as has been already mentioned in the computing, quantum computer section, what we have done already was to fix some limit by trying to look for this radiation, which we didn't find, so we only set limits on the parameters of the collapse models, which look like this. So we excluded the models which are not depending on mass, so in which the coupling constant does not depend on mass. We are still open in the models which depend on mass, which have some mass dependence. I had the chance to talk to Steve Adler in Princeton 2 weeks ago. He's working presently on colored noise, which is very fascinating because also has to do somehow, we had a controversial discussion with Cohen from the free will theorem, Cohen and Conway. So because the non-white noise models, staying to Steve Adler, are kind of in a disagreement, so they would disprove the free will theorem as demonstrated by Cohen and Conway. So that's all for the collapse models. The other thing which we are doing in Gran Sasso has to do with stability of the matter. So we look for violations of Pauli exclusion principle, which has to do with quantum gravity models. So Also it's the philosophy. So we look for atoms, atomic transition, which shouldn't be there, trying to bring a third electron down on the fundamental level, setting limits on the probability of violation. Of course, we would be happy to find it. That's part of my group, and I have to tell you at this picture that not everybody is there because we had an engineer who discovered it's claustrophobic. So we had to bring him out immediately. He never went back in the underground laboratory, actually under the mountain. So it's a tough environment, not only for science, but also for psychological reasons. You need to be tough to go 5 kilometers, both ends, in the belly of a mountain. Thank you very much.